Hey everyone, welcome to this explainer. Today, we're going to demystify AI tokens and really pull back the curtain on how AI actually processes the text we type every single day. I mean, we interact with artificial intelligence constantly now, right? We're typing in questions, we're pasting in giant documents, and we get these instant, incredibly complex responses back. But beneath the surface of all that seeming magic, there's actually a very specific mechanical process happening to make it all work.
So you got to wonder, how does AI actually read our language? When we look at a screen, we just see letters, words, and sentences. But computers, at their very core, they only understand numbers. So if you've ever wondered how a massive model takes your super conversational prompt and digests it to formulate this brilliant answer, well, you have to understand the mathematical bridge between human language and computer processing. It's a system built entirely on statistical probabilities, and that sets up the exact problem that tokens are designed to solve. So let's dive right into this.
All right, Section 1. What is an AI token? It's really the fundamental unit of AI.
The crucial point here is that we really shouldn't overcomplicate this concept. A token is simply a small piece of text that an AI model reads and understands. That's it. It acts as the absolute fundamental building block for AI comprehension. You can kind of think of tokens like the syllables of a word, or maybe the individual puzzle pieces of a sentence. It's not always a whole word either. Sometimes it's a chunk of a word or even just a single character. By breaking our totally messy, complex human languages down into these simple, bite-sized tokens, the AI can finally begin to process what we're actually saying. And because it's working with these discrete little puzzle pieces, the model can use probabilities to predict which specific token is statistically most likely to come next. To see how this works simply, let's take a look at the phrase, artificial intelligence is changing the world. Now, when you feed that into an AI, it doesn't read the sentence smoothly like you or I would. It literally chops it up mathematically. The word artificial becomes one token, and it gets assigned the number 1012. Intelligence gets the number 29,871. The word is gets 374. Changing becomes 9123. The is 279. And world gets 6891. And the meticulous nature of this process is just fascinating to me. Even the period at the very end of the sentence is its own separate token, assigned the number 13. Why? Well, because punctuation dramatically changes the context of a sentence, right? Which means it drastically shifts the probability of what word should follow it. So this whole process literally transforms our text into a strict sequence of numbers, so the AI's mathematical core can actually compute it.
Moving on to Section 2, the journey of a prompt, from user to output.
Now that we know what a token actually is, let's speed things up a bit and trace the journey of these tokens from the exact moment you hit enter on your keyboard. It all happens in a really simple, logical three-step flow. First up, we have step 1, which is the input. And this isn't just your immediate user question. The system actually gathers everything. The system prompt running in the background, your conversation history so it remembers the context of what you were just talking about, any retrieved documents you might have uploaded, and of course, your actual question. All of that text gets converted into input tokens. Then, step 2. All those tokens are fed directly into the model. This is where the magic happens. The model crunches those millions of numbers, rapidly calculating the statistical probability of what should logically come next. And finally, we hit step 3, output. The AI generates its response in brand new tokens, which are then instantly translated back into the readable text you see on your screen, generating a sentence like, "The world is changing because of artificial intelligence."
Which brings us to Section 3, tokens equal cost. Let's talk about how AI usage actually impacts your wallet.
So here's why understanding all this matters to you directly. Every single word you type into an AI and every word the AI generates back to you acts like a tiny currency, because frankly, massive processing power isn't free. You're ultimately charged based on the number of tokens used. And there's a really distinct difference in the pricing structure here. Input costs are usually around 50 cents for 1 million tokens, but the output costs, what the AI actually has to generate, is significantly more expensive, sitting here at about $1.50 for 1 million tokens. So why the huge gap? Well, it takes exponentially more computationally heavy lifting for the model to generate brand new tokens than it does to simply read and process the ones you already provided to it. Processing is just mapping and holding numbers, right? But generating requires the model to actively calculate these massive probability trees just to create something entirely new.
Let's run through a practical math example to show how these millions of tokens actually break down in everyday usage. Say you paste a pretty long document into the chat and ask a specific question about it. Let's call that 5,000 input tokens. The AI then writes a solid summary back to you, which takes, say, 1,000 output tokens. Your total usage is 6,000 tokens. Based on those prices we just talked about, this entire interaction boils down to mere fractions of a cent, specifically $0.008. So while it's absolutely true that tokens equal cost, for daily individual use, it remains incredibly cheap. However, if you're an enterprise running automated interactions, those fractions of a penny scale up incredibly fast. Millions of interactions a day can suddenly turn into a $10,000 monthly bill, which is exactly why token efficiency is a major engineering priority right now.
All right, last up is Section 4, the context window, essentially the AI's memory limit.
Finally, we have to talk about the absolute limit to this entire system. The context window is the strict limit where all tokens, meaning your input plus the AI's output combined, must fit for the model to actually function. The simplest way to think about this is that the AI just has a finite short-term memory capacity. It's kind of like a speedometer gauge on a car maxing out. If you try to paste a giant book that's 100,000 tokens long into an older model that only has an 8,000 token context window, it's just going to fail. Or it will simply forget the very beginning of your prompt. The sum of your prompt, the background history, and the response it's trying to generate absolutely must stay under this strict threshold, or the model just totally loses its train of thought. Thankfully, while older iterations maxed out at just a few thousand tokens, the newer models are rapidly pushing those limits into the millions.
Which leaves us with this final pretty provocative thought. What's going to happen when AI models finally have a truly unlimited context window? Right now, we manage tokens, we worry about strict context memory limits, and we have to carefully strategize our prompts to save costs and stay within that gauge. But as processing power continues to explode, and those context memory limits eventually stop holding back these models. I mean, imagine allowing you to feed an AI the entire history of a company or an entire digital library in a single prompt. How is that going to change our relationship with information forever? Definitely something to think about the next time you watch an AI model generate its answer, token by tiny token. Thank you so much for joining me for this explainer, and I hope this really helped pull back the curtain for you.